Hello and welcome to Saurabh Sir's classes. Today we are discussing the JNU paper. This question talks about an integral which is log x dx within the limits 1 to 2, and it is known that log 2 is roughly around 0.693. So the integral 1 to 2 log x dx can be done using integration by parts. Integration by parts, where we take dx as the integrable function and log x as the differentiable function. So we first integrate the integrable function, which means dx becomes x. We keep the differentiable function, which is log x, and this is from 1 to 2, minus integral of 1 to 2. We integrate the integrable function, which is x, and differentiate log x, which is the differentiable function, which becomes 1 by x dx. So this becomes equal to 2 log 2 minus integral of 1 to 2 dx, which is 2 log 2 minus x from 1 to 2, which is 2 log 2 minus 1, and the value of log 2 is 0.693, so 2 into 0.693 minus 1, so this is 6, 8, and then 12 and 1, 1.386 minus 1, which is 0.386. So this is the value of this integral. The next question talks about a function fxy defined as x square minus y square, and another function which is 1 minus xy is equal to 0, and we are asked to maximize function of xy. So here we can clearly see that 1 minus x minus y is equal to 0 means x plus y is equal to 1. So therefore x is 1 minus y. So therefore x minus y would be 1 minus 2y. Now f of xy can be written as x plus y into x minus y. Now x plus y is given as 1 and x minus y becomes 1 minus 2y. So therefore the function fxy will be maximum when f dash of xy will be 0. Now if we take the first differential of this function fxy with respect to y, then fxy dy is equal to minus 2. That means this would be a straight line which will pass through the point y equal to fxy equal to 1 and y equal to 0. So this will be a straight line with a negative slope of 2 passing through this point, and therefore the maximum value will tend to infinity as y tends to minus infinity. So therefore this function will not have a definitive maximum. The next question talks about a gambling game where 2 fair dice are rolled, and it is told that you will gain ₹2 for any even number that shows up, and you will lose ₹1 for any odd number that shows up. So what is the overall expected gain or loss from the game? So therefore we have to understand that the 2 dice are independent. So therefore there is no dependency of one dice over the other. So consider the first dice. Now the first dice can show 1, 2, 3, 4, 5 or 6. So there are 3 odd numbers which are 1, 3 and 5, and there are 3 even numbers which are 2, 4 and 6. So probability of odd number showing up is 3 by 6, which is half. So probability of even number is also half. So therefore the expectation of loss or gain or loss from the first dice would be probability of odd into the value that is gain for odd, which is -1, plus probability of even into the value that is gained for even, which is 2. So therefore the overall expectation is half into -1 plus half into 2, or minus half plus 1 is equal to half. So since the two dice are independent, therefore there is no relationship between whatever the first die shows and the second die shows. So for the second dice also, the expectation of gain or loss would be half, exactly the same. So therefore the overall expectation of gain or loss will be half plus half, or 1, rupees 1. Rupees 1 gain. The next question says that the probability density function of a random variable x is given as fx equal to c into 4x minus 2x square when x lies between 0 and 2 and it is 0 otherwise. What is the value of f1? And we cannot give the answer in terms of c. So therefore we have to find the value of c. Now since the probability density function is given as c into 4x minus 2x square in the range x lie between 0 and 2, so integral of fx dx from minus infinity to plus infinity is the total probability of x over its entire domain. So that is equal to 1. So this can be broken up into integral of minus infinity to 0, and the value of fx in that range is 0 dx, plus integral of 0 to 2, the value of fx in that range is c into 4x minus 2x square dx, plus integral of 2 to plus infinity, again the value is 0 for fx in that range, so 0 into dx. So we can clearly see that the first term will be 0 and the third term will be 0. So we are left with the second term only. So therefore we get 2c integral of 0 to 2 into 2x minus x square dx is equal to 1, or 2c into x integral of 0 to 2 2x dx minus integral 0 to 2 x square dx. So therefore and this value is equal to 1. So therefore 2c into integral of 2x dx is x square minus integral of x squared dx is x cubed by 3 within the range of 0 to 2 is equal to 1, or 2c into 4 minus 8 by 3 is equal to 1. So therefore 2c into 4 by 3 is equal to 1. So therefore c is equal to 3 by 8. So therefore value of f1 would be equal to c, which is 3 by 8, into 4 into 1 minus 2 into 1 square. So 4 minus 2 is 2. So this is 3 by 8 into 2, or 3 by 4. So f1 is 3 by 4.